Welcome to this video tutorial on the topic of grinding versus milling. This video features an overview of the various options available, such as grinding as well as wet and dry milling, including the corresponding instruments. More detailed information on the relevant manufacturing methods can be obtained in additional video tutorials on the topics of grinding, wet milling, and dry milling. Various manufacturing methods are available to you, depending on the relevant material and on your grinding and milling unit. With grinding, the block is processed into the desired shape with friction force using diamond-coated instruments. With milling, this takes place using rotary cutters made from hard metal. While grinding is required for most blocks, some softer materials can also be milled. These include, for example, blocks made from PMMA and composites. Designs made from zirconium oxide or a sintered metal can also be milled, as these materials only achieve their high final strength following the sintering process. Zirconium oxide blocks in particular, such as CEREC zirconia or the in-chorus TZI block, can also be dry milled. Let's take a look at the benefits that the wet milling manufacturing process provide, as compared with the grinding process for the various materials. By wet milling zirconium oxide, we not only achieve more even surfaces and edges, but also sharper margins. In addition, there is no chipping, and sprue locations are significantly reduced. Similar performance is achieved when milling polymers and composites. The sprue locations are also reduced here, which in turn reduces the time required for post-processing. The surface is also shinier than with a ground restoration. Another benefit is the reduction in material residue deposits on the instruments, thereby helping to preserve them. The dry milling option is only available to you for zirconium oxide. The main benefit is that you do not have to wait at least 15 minutes for the restoration to dry before sintering it. The potential risk of particles in the water tank compromising the color of the restoration is also reduced. Dry milling zirconium oxide does not yield more precise results, nor does it speed up the net manufacturing process. Next, let's take a look at the instruments required for the three manufacturing methods. With wet milling, the Shaper 25RZ with a shorter milling head is used, together with the Finisher 10 for more detailed milling results. You position both milling cutters in motor set 1, specifically with a 4-motor grinding and milling unit. The Shaper 25RZ is used on the left and the Finisher 10 on the right. Please note that a higher torque is required both for inserting as well as removing the Shaper 25RZ. You achieve this with a torque wrench with a square bearing form, and which features the additional description HT, which stands for high torque. The torque wrench with the triangular bearing form is used for the Finisher 10. The Shaper 25 is required for dry milling. This is a 4-tooth milling cutter with a radius of 1.25 millimeters that features longer teeth and grooves for more efficient removal of dry zirconium oxide material. The Finisher 10 is designed for the fine details, particularly in conjunction with CEREC zirconia and in-chorus TZI C blocks, which feature a sintering shrinkage rate of approximately 24%. The torque wrench with triangular bearing form is used to insert both instruments. They are also positioned in motor set 1 with 4-motor grinding and milling units. The instruments shown in the image, along with the associated torque wrench featuring the triangular bearing form, are used for grinding. For further information regarding which material can be ground or milled using which instruments, please visit our Dentsply Sirona website. Thank you very much for your attention. We would like to wish you every success when working with CEREC.